In our final section of this chapter, we're going to be working on rewriting equations and formulas. And for your vocabulary, you're going to want to understand what a formula is and what is a literal equation. So let's take a look at some of this information. So if we look at these equations, 2x plus 5 equals 11 and 6x plus 3 equals 15, you can see that they have the same basic structure, and they have a general form of ax plus b is equal to c. So this item, ax plus b is equal to c, is what is called a literal equation. It's a literal equation because the coefficients and the constants have all been replaced with letters. So when I solve a literal equation, I can use the result to solve any equation that has the same form by plugging in the other items. So if we want to solve the literal equation here for x, then we can use the solution to solve a specific equation. So if I solve the literal equation for x, the first thing I'm going to do is divide by c. X plus b is equal to c divided by a, and then I'll subtract b. So x would be equal to c divided by a minus b. If we look at this particular equation I have, then this is a, and this is b, and this is c. Then I can go ahead and solve this by taking these values and plugging them in. So I'll have 9 divided by 2 minus 1. So 9 divided by 2 is I could say that's 4.5 minus 1, and the answer would be 3.5. More proper, however, would be to stay in the fraction, because there's no reason for me to switch to decimals unless the problem has somehow instructed me to do that. So 9 halves minus 2 halves, I've converted the 1 to be 2 halves, so I have common denominators, will be equal to 7 halves. And this really is the more proper way to solve the problem. Okay? When we have more than one variable, an equation with 2 variables, and we can have equations with 3 or 4 or 5, such as 3x plus 2y is equal to 8, or a formula that has 2 or more variables, like area is equal to 1/2 base times height, they can be rewritten so that one variable is a function of the other variables. So what we would call that is solving for a variable. So I could solve for x, or I might solve for h. So if I want to write the equation so that y is a function of x, that means I'm solving for y. This is the form I want it to be in. So I'm going to be isolating y, and the first thing I'm going to do is subtract 2. 6y would be equal to 3x, and I have 4 minus 2 is 2. And then I'm going to divide by 6. So y will be equal to 3x plus 2 divided by 6. If I distribute my division, I'll have 3x divided by 6 plus 2 divided by 6. And when I simplify, this will be x over 2 plus 1/3. Okay, if we look at a formula like a geometric formula like this one, the area of a circular ring, my area is equal to 4 times pi times the value of p times the value of w. So if I want to solve this for p, I'm going to start with the original equation, 4 pi pw. Now you'll notice all of these items are being multiplied, so to solve for p, all I have to do is divide by 4 pi w. 4 cancels the 4, the pi cancels the pi, the w cancels the w, and I'm left with p is equal to area divided by 4 pi w. So now, if I take my supplied values, I'll have 905 feet squared divided by 4 pi times 9 feet. Now, the feet is going to eliminate the squared part of my feet here, so my answer is going to be in feet. So the p-value is going to be equal to, actually, let me go ahead and move this up over here. The p-value is going to be 905 divided by 36 pi. Okay, now I could simplify that and make it a decimal, or in this case, I'm going to go ahead and leave it in this term. Okay, moving on and looking at another type of formula. I'm visiting Toronto, Canada, and I'm given this forecast. So you'll notice that all of the temperatures are in centigrade. Oh, but wait, I'm from the United States. We use Fahrenheit. So there's a formula that allows me to convert Fahrenheit. This is the formula that allows me to convert Fahrenheit into Celsius. But that's not really what I'm going to want to do. What I'm going to want to do is I'm going to want to put in Celsius, because these are all supplied values of Celsius, and I want to get Fahrenheit out. So the first thing I want to do is rewrite the formula. So I'm rewriting the formula, 5/9 times F minus 32. So the first thing is I want to get rid of the 5/9. I don't really want to distribute it. Right now it would make more sense to multiply both sides by 9/5. So I'll get 9/5 Celsius is equal to Fahrenheit minus 32. And if I add 32, I can say 9/5 Celsius plus 32 is equal to Fahrenheit. So now I've taken this formula that relates Celsius and Fahrenheit, and I've set it up so that I can plug in Celsius and get out Fahrenheit. So they'd like me to find the low temperatures for Saturday and Sunday. So Saturday and Sunday would be this low and that low, so 14 and 10. So for Saturday, I'll have 9/5 times 14 plus 32 will be equal to Fahrenheit. So 9 times 14 is 90 plus 36 would be 126 fifths, plus 32 will be equal to my Fahrenheit. I'm going to go ahead and leave it as a fraction. Well, I'm going to do, actually I'll change it, I'll do it as a decimal. That's really more likely what we would do. So 126 divided by 5, 25.2. So we'll have 25.2 plus 32, and that's going to be 57.2 degrees Fahrenheit for Saturday. And if I do the same thing for Sunday, I'll have 9/5 times 10 plus 32 equals Fahrenheit. 5 goes into 10, leaves 2. 2 times 9 is 18, plus 32 is equal to Fahrenheit. So 50 degrees Fahrenheit is the low for Sunday. Okay, and that's working with, when we have formulas, we can solve them for any variable, the same with any other type of equation. And that's it for our Chapter 2 lessons.